In this lab, we will continue with building classification trees for the biodegradable data and performing the data analysis. In the following code, we fitted a really large unpruned classification tree to the training data. We found there were 22 variables actually used in tree construction as it was listed, and the misclassification rate was 0.08523. Then we computed the test. We split the data into train and test, and we computed the test error. The test error was higher compared to the train set error, and also the tree misclassification error rate was higher. So the test error, which is also misclassification error, is higher than the train set error. Okay, so then after then we created the function fhead.tree and errors, and we used that to calculate the train error and the test error. And we also computed the error manually without using those functions by looking at the classification table for the test set and the train data set. Now in this lab we are going to write codes. And we're going to consider pruning the tree using cross-validation with deviance. So we set.seed, we pass this command set.seed of 1 2 3 4 5 because this cross validation command will give different values every time we run. So we in order to have the same value, we have to do the pass the command set.seed of 1 2 3 4 5. Cross validation k equal 10 and method equal deviance is by default. Let cvr equal to cv.tree and bracket fit. So this fit was a model that we used to fit the train set. So fit is equal to tree of class equal to addition of all the variables and data equal biodeg, comma, minimum deviation equals 0. So this was growing a really large unpruned tree. So fit is the very large unpruned tree from the biodeg data. So we have when we pass the command cv for cross-validation.tree of fit, we get size, we get deviation, we get k, we get method, we get attributes. Print the summary. Summary of cv.r gives size 57, deviation 57, k 57 and method 1. In the following code, we find the location of a smallest deviance. Find the smallest deviance to prune the tree. So, um, so cv.r, at deviation, we find the minimum of it, and passing the command which dot minimum, that will find the minimum of the index, and that comes to 44. In the following code, we produce a prune tree based on selecting a cost complexity parameter value. Cost complexity parameter for minimum deviance. So cv.r at k. K is the cost complexity, and the uh, the and in the bracket we'll have j dot minimum, and that is 44, and that's the smallest deviance to prune the tree. So let k equal cv dot r at k square bracket j dot minimum, and we get 14.0893. So if we look at k, and if we look at 44, index 44, we have 14.089129. So this is the best cost complexity. Then the prune tree we obtain with cost complexity. So let fit1 equal to prune.tree of fit, comma k, which represents the cost complexity, equal k, which is 14.0893. So this is what we get. So the root we have 1055 1349 point and NRB. Then the child of that root is SP max BM less than 3.6775, and so on. And then the child of that is F02 CN less than 2.5, and then the child of that is SPMXL less than 4.984, and the child of that is N0 less than 1.5, and the child of that is SM6BM less than 8.2405, and child of that is SP max L less than 4.7965, and child of that is NCP less than 0.5, and child of that is NCP greater than 0.5, and child of that is HYWI BM less than 2.562, and child and another child is HYWI BM greater than 2.562, and so on. In the following code, we plot the prune tree selected by cost complexity parameter value. So plot fit1 text bracket fit1 comma pretty equals 0 comma all equal true comma CEX equals 0.5. So we get a tree like this, where the leaves are the classes, the response variable. Comment: comparing to the plot of unpruned tree, many internal nodes are gone. In the following code, we will compute the training and test errors for the prune tree using the errors function. So call the function errors and input fit1 comma fhead.tree, that is a function, comma train comma test. So we get train error equal 0.1420455 and the test error equal to 0.1214421. Do you think the pruning helps? The training data set is unreliable to use for comparison as it is biased. We compare using the test data set. For the unpruned tree, the test data set error is, so for the unpruned tree, let's have a look at the test data set. So we had so this is the prediction. So we had for the very large tree we had 0.1783681 has the test error, but then when we model a fit, and for that the test error for fit was 0.0512334, and then we pruned the tree using the cost complexity. So we we passed the command prune.tree of model fit, comma k equal k, and then the test error is 0.12144421. So for the unpruned tree, the test data set error is 0.01521334. After pruning by selecting cost complexity parameter value, the test data set error is 0.12144421. We conclude that pruning by selecting a cost complexity helped in getting a simpler model, but the misclassification error rate is higher.